7, they say, hey, in the diagram below, you've got two triangles. You've got a larger one called ABC, and you've got a smaller one called DEC. And those triangles are similar. And whenever you see similar, and especially when you see values like numbers, you should be thinking proportion. Because I bet you they want us to find some value. And that's pretty much every single time going to be found by creating and solving a proportion for the missing piece. And that's the first thing I want to identify is what do they want me to find? And they want me to find the perimeter of triangle DEC. And if we recall, the perimeter is found by just adding all the sides together. And there really is no commonly accepted way or destination as to where you put the perimeter. Sides like AC go on the outside, and angles would go on the inside. But perimeter is just like a calculation we keep somewhere else. So I'm going to keep track of that by putting it inside of the corresponding triangle. So I'm talking about DEC, and that is what I'm looking for. So I'm just doing that to create a visual, because I bet you they're going to give me the perimeter of the other one. Because the perimeter of the blue is the thing that corresponds to the perimeter of the red. And it'd be really helpful if those were like in the same position, because now I'm building this connection. There's something connecting this 30 and that x. They're like terms. They're corresponding pieces. And I can put them into a ratio, because similar figures, you can compare corresponding pieces to tell you information about other corresponding pieces. And now this problem is really getting simplified too. Well, we have to find which lengths will be corresponding sides. Is it going to be 12 and 7, or is it going to be 12 and this other side 5? And I think the trap here is like most people go, oh, this is the right and this is the right, so it's, right sides on right sides. But honestly, you have to think about how did this take place, and how did we go from the red to get to the blue? And that was by a reflection. You're flipping. So this 12 will actually flip onto that 7. And I think I can kind of show that. I think I can take that and I can rotate, flip horizontally, and now you can see that 7 is the thing that lands on 12. They're the corresponding pieces. But if you didn't see that, that's okay. We can use our similarity statement. This is super clutch. And we can see that A and C, the only information we have about this triangle, the first and the third letters, that is going to match up with the corresponding first and last letter, C and D. And that's how I know 12 and 7 go together. So I took something from the red, I put it on top, so I got to take this 12 and put it on top. I got to divide that by the corresponding piece from the blue. And now we're ready to solve the perimeter by butterfly multiplying, so we'll get 12x, and then 30 times 7. Ask our calculator. 30 times 7, 210. And we're going to divide both sides by 12 in order to isolate our variable. And we'll figure out x equals whatever 210 is divided by 12. So 17.5. So x is what we were looking for. It's the perimeter. So we're going to write a nice little sentence. The perimeter of triangle DEC is 17.5. We're going to call it a day and earn ourselves 2 points on that Regents. See you in the next one.